This video is going to take a look at how to use algebra to describe a pattern to write an expression for the pattern. So if you take a look at this, first of all, there is a typo on the screen. This here should say term number, not team number. Okay, but if we're looking at that, we have the term number 1, 2, 3, 4, and then its corresponding terms, 5, 8, 11, and 14. So first of all, we want to look for, is there a common difference between consecutive terms? Common difference is an answer to a subtraction problem, and consecutive just means terms that are one after the other, like term number 1, then term number 2, number 3, etc. So if we look at each one of the terms, there should be a common difference of 3 in between, because if I look at 14 and 11, the difference between those is 3. The difference between 11 and 8 is 3, and the difference between 8 and 5 is also 3. Because that sequence has a common difference, we can also call it an arithmetic sequence, which just means that it has a common difference. So we want to use this fact to be able to predict what our term numbers are for the particular term that's given. So the first one asks us to predict the term for the term number 7. What I could do is I could say, okay, I have term number 4 in the table, so that'd be 5, 6, 7, right? And the pattern is that we're increasing by 3. So the fifth term would be 17 because I'm adding 3. The sixth would be 20, and then the seventh then would be 23. I could continue doing that for the 15th and the 59th, but that would take forever. So instead, I would want to come up with some kind of an expression so that I can find out what that number is easier. And the expression for this particular term or pattern is 3n plus 2. You should notice, and we'll review this in the next slide, the 3 is the common difference. So the common difference is always multiplied by your variable, which normally we use n, and then we have to see what we can add or subtract to get to the term that's in the table. So for example, if we take the common difference, which is 3, you always want to start with the first term in your table, which is always going to be term number 1. So I want to multiply 3 times 1. 3 times 1 is 3, but I didn't get a 3 in my table. I have a 5. So what can I do to make a 3 into a 5? I can add 2, right? Because 3 plus 2 is 5. So to make my expression 3n plus 2, I have to take out that 1 and substitute with an n. So I have 3 times n, and then I added 2 to get it to be that 5. So for the 15th, instead of having to do all of that, I could have gone in here and I could have substituted in my term number, which is 15. So I would have 3 times 15 plus 2. 3 times 15 is 45, and if I add 2 to it, I get the 47 that we have over here. So that is exactly what this slide shows you again here. So again, to be an arithmetic sequence, consecutive terms have to have a common difference. Then to find the nth term, you want to take 1, because the first term is always term number 1, and multiply it by your common difference. Then you have to add or subtract to get the value that's in the table. 3 times 1 was 3, right? Because our common difference in the 1 was 3, and we had a 5 as our first term, so we had to add 2 to the 3 to make it to be the 5. So if we're looking at this pattern, we can also look at the patterns in terms of a list. So if we're looking at 1, 3, 5, 7, 9, 11, 13, 15, we have to first find out, is there a common difference? You should see that yes, there is a common difference, because as you go through the list of terms, each one increases by 2. So is it an arithmetic sequence? Yes, it's an arithmetic sequence. Why? Because it has a common difference. So if we were going to make our expression to be able to predict all those terms without having to extend the sequence to the 10th term, the 20th term, the 32nd term, etc., I would take my common difference, which was 2, multiply it by 1, because my first term is always term number 1. So 2 times 1 is 2. But our first term in our list isn't 2. Our first term is 1. So how can I get from a 2 to a 1? I can take away 1, which is what gives me the 1. So in my expression, I have my common difference. I replaced the 1 with my variable, and then I subtracted 1, so my expression is 2n minus 1. I can do the same thing for here. Is there a common difference? You should see if you look at the y values, the terms, there is a common difference because the terms are increasing by 5 each time. So to find my expression, I take my common difference, which is the 5, I multiply it by 1, which I get 5. But if I look in my table, my first term is in 5, it's 6. So to get from 5 to 6, I have to add 1. So my expression then becomes my common difference. I take the 1, I replace it with my variable, the n, and then we added 1 to that, so my common difference is 5 times n plus 1, which gives me my expression to find out the terms for any other term number.